Hey guys, so today I'm going to look at the next part. We've got exponential growth and decay. Before we jump into that, I do just want to go back to this question 3b. Just fixing up an error I'd made in that last video. The area under the curve definitely works, but that's when we're looking at the velocity graph. Okay, so the area under the velocity graph will give us the total distance traveled. Okay, if I look at this question again though, they gave me the displacement graph. So it's a nice one to be able to just sketch. So I knew it was an upside down parabola passing through 0 and 4. And by just doing that, it makes it a lot easier actually than having to do the integral and so on. Because I can just see that from, 0 to 2 seconds, it travelled 4 centimetres. I subbed in 3 into my equation and it came out as 3. So that meant that from that second to third second, it travelled another 1 centimetre, making the total distance travel 5. So the area under the curve definitely would have worked had it been a velocity, not displacement. So just make sure you fix that up in your notes for me. But otherwise, exponential growth and decay, you've seen bits and pieces of this before. But otherwise, it's the term used to describe a special rate occurring in many situations. Describes the quantity that is increasing or decreasing according to an exponential function. So we can represent it with dn over dt, n or whatever letter they're using, n common for this, or p for population, n for number, p for population. But otherwise, the first little proof here we've got is, given that n is equal to a the kt, the rate of exponential growth is dn dt equals kn, where k is the growth or decay constant. So the proof, it's actually a really nice straightforward proof. We start with the formula they give us, n is equal to a the kt. When I differentiate the power, I get k being the constant that, or the value that's the coefficient of t, comes out the front and times us. And just subbing it back in, since n was equal to a the kt, then I'm just filling that in where n is giving me my proof there. So in that particular case where you have something in the form of a equal to the kt, when you have a k value that is greater than 0, it's going to be a growth. If it is less than 0, it's going to be a decay. All right. Otherwise, the rest of the information is just knowing our exponential graphs back to year 11. So let's just jump into a question. The first one here says the number of bacteria in a culture is given by that formula, where T is measured in hours. If 6,000 bacteria increase to 9,000 after 8 hours, find K. All right, so after 8 hours, so it went from 6,000, so A is the initial amount. And N is the new amount, I guess we could say. So it's what they told us was the 9,000. So the initial amount was 6,000. And it said that T was 8 hours. So we sub it all into our formula. Let's see what we get. And it wants 3 significant figures, so we'll go there we go. Okay, the number of bacteria after 2 days. So now we know that the formula can be n equals the initial amount, which was 6,000. We know our k value. And we want to know after 2 days, so at t equals 2. Actually, t was hours, wasn't it? So t equals 48. Careful of that. Okay, approximately 68,399. The rate at which the bacteria are increasing after 2 days. Keyword there, rate. So what do we need to do? The derivative. Now we do know that we proved that the derivative of dn, so dn dt, is k times n. We did prove that above. Otherwise, you can just, differentiate the equation and go from there, but something a bit quicker. N being the number of bacteria after 2 days, so we just work that out above. So then we get our k value. And that's it per hour. Okay, when the number of bacteria will reach 1 million. So now we want to know, okay, when. So that's solving for t. So solving for 1 million. Going to log both sides. All right, there we have it, just solving our exponential equation. Okay, there's 2 more here. Give it a go if you like. It's very similar. Pause the video. I'll finish off these and pop it in my booklet solutions, so you'll see them on OneNote. So check your answers with mine once you finish watching this video.